If you are an Arduino project creator, I know everyone like to make LED clocks. Therefore, I have created one LED clock earlier. However, I understood that there are some time issues when the time being passed. A lot of my fans complain that there is a difference between the real clock and the created LED clock shows a time difference like 5 minutes. As a solution, I decided to create another LED clock with new RTC module. Since I want to add some additional features, I decided to build it without seconds part. Therefore, this LED clock will show only hours and minutes only. The special thing is that I am going to use the DS3231 RTC module, and also it is included a rotary encoder to change the hours and minutes as well. There will be an additional option to show the PM AM time, but I have added only one LED to indicate the PM on or off. If we go to the components, you need a lot of LEDs, PD135 transistors, TIP32 transistors, and as usually you know, the basic components for Arduino projects: atmega 328 chip, 1 kilo ohm resistors, 100 UF capacitors, 10 UF capacitors, 7805 regulator, 16 MHz resistors, 22 PF capacitors, ferro boards, soldering wires, etc. When you use a rotary encoder, it is easy to use a rotary encoder module. If you use only a rotary encoder, you have to use additional resistors and capacitors as well. You can see all circuit diagrams and additional details from my website www.setnfix.com. Shall we start the project without delay? This robot has around 90 horizontal dots and about 36 vertical dots. You can use same size of robot. It will be easy to follow my project. Then, since we need to use the same digit in the same pattern, we have to draw a LED pattern in each and every robot. So I decided to draw the LED holes using a marker pen like this. You can follow the same procedure to mark your LED on your robot. Do not worry, even though is marked the LEDs on the robot, when you fix the LEDs, you can't see the marked lines. Now, follow the lines as I show here. You can see once it is marked, skip 3 dots and mark, again skip 3 dots and marks. Then you can mark the second line as well. Once all the LEDs are marked, you can start to solder the LEDs. Since the one side is over, then you can mark the LED to the horizontal side. Since you have to understand it clearly, I am not going to fast forward the video. If you think you can do it, you can skip this part. However, do not skip any additional dot. You did like that, your digit will not be equal. Unequal digits will show ugly to your project. Therefore, try to stick with the same pattern, especially when you mark the LED in the middle. Follow the video and mark correct. You have to mark same pattern as I said earlier in all the 4 digits. Follow the video. Marking this part is very important. I also faced some difficulties when marking this part because I have used there are 3 LED lines to the middle. Count the correctly and mark correctly and make sure before soldering all the patterns are unique and neat. Once this part is over, you can repeat the same to the other end as well. If you're familiar with the before, you can do it easily. Then you have to cut the LED pins in order to suitable with the project and easy solder. There are 2 types of LED cuts. So one is you have to keep couple of millimeters in the negative side and cut. You can see how it is doing. You need few LEDs like this for a one line. And there is another type of cuts, the same pin, but you need to keep more than double to previous. You can see how it is doing. You need same number of LEDs for a line. Once the set of LEDs are cut, you can use the hole you have marked in your robot. Make sure you install the LEDs in the same direction to the mark. Otherwise, you will face a lot of troubles when testing the LED. Set the LEDs as I show in this video. Follow the video and do as you can see the completed SSD with the LED. There should be 8 SSDs using LEDs. The additional zeros you can cut it down. And before starting the project, you have to test the LED connections, solderings, polarities, etc. Now use your multimeter and check the connection. If you have decided to use common positive or common negative, you can use whatever you like, but check all the connections are soldered better. In this project, I have decided to use common positive SSDs. Therefore, I have connected all the positive pins together in one SSD. Then other negative lines are separately connected. There are 7 negative lines. Once a fault is found, you can correct soldering those.
The LED connections, giving power to each sections.
Once you are satisfied with the connections, you have to check the LED bulbs. You know, SSD has 7 lines we call A, B, C, D, E, F, G. Since common positive SSD, I'm using positive side around 2.1 volt. Do not increase it. Then check each line whether the LEDs are working or not. Sometimes it may burn due to manufacturer faults or by your hand, because sometimes of the temperature of your soldering iron will kill your LEDs. If you are using a soldering station, make sure not to increase more than 300 Celsius, and also do not heat the LED or do not heat the soldering too much. If you can use an ordinary solder, it is better to use 30-watt soldering iron. Sometimes you have mistakenly changed the polarity, then it will make LED not work. So check all the LED bulbs whether all the LED bulbs are burnt well. If you found the burnt LED, mark like this and replace it. In my practice, I have also burned more than 50 LED, so I had to replace those before starting. Make sure do not heat too much when you are soldering. Once all the SSDs are completed, you have to connect all the SSDs together. Even though there are only 4 SSDs, finally I decided to add the circuits as well. Therefore, I created more 2 SSDs to show the circuits. When you connect, do not forget to continue the same thing if you want to keep the SSDs common cathode or common anode. So all the anode of each SSD should be connected together. But there are 6 separate anodes. Do not connect anodes of LEDs. Do not connect the anodes of SSDs together. Then you have to connect all the A ranges. Then you have to connect all the A sides together, all the B sides together, all the C sides together. Likewise, A, B, C, D, E, F, G as one line. Once everything are connected, I try to test to ensure that the LEDs are well. Don't forget that if you use a lot of LEDs, it will take 4 amperes to activate the LEDs. I think my connections are okay. tested the SSDs, now you can start soldering circuit. Make sure you are using that the transistor can work with more amperes, because there are more LEDs, it will take more. Solve the components according to the circuits. I will upload the circuit to my website and keep the heat of your soldering iron in order not to burn your parts. I have a lot of LEDs and transistors that have been burned due to the high heat. It can be recommended to use around 300 to 350 Celsius of your soldering time. This is the circuit diagram, complete circuit diagram, so you can follow that circuit. Once the parts of circuits are soldered, you can connect this RTC module to the circuit board using a female header. If you connected a female header, you can remove until the program is completed. Otherwise, due to some wire shortages, your RTC module will be burned. It will be a good cost for your product. After the soldering part is completed, I will show you my project for completing the body. I decided to use red LED for second part and also smaller than the other SSDs. This is the circuit I have completed. As I said earlier, you can remove the RTC module if you do not need. In order to check the wiring and the programming part, I used a testing code to check all the LEDs are working well. So you can use that program as well to check your circuit. I will meet you after a few days having completed the LED project. There are more works to do for coding part. So until then, stay with SetNFix.